Alright, today we're going to discuss another way for measuring angles called radians. The radian is the measure of the central angle of a circle that intercepts an arc equal to the length of the radius. So what that means is, if a circle has a radius, if I take that exact same distance, if I were able to pick up that radius and move it to the edge of the circle and go that exact same distance along the edge of the circle and connect back to center, this right here is 1 radian in size. It's taking the radius, measuring it off on the circumference of the circle, and saying this central angle is 1 radian in size. Kind of like 1 radius, but 1 radian. Okay? So to find out if you have an arc length, you have a distance around the edge of your circle, and you divide that by the radius, that'll tell you how many radiuses there were, and that's the number of radians there are. So this is the formula for finding how many radians you have. Take your arc length. Remember, an arc length is a piece of the circumference. I'll say piece of the edge of the circle. Divided by the radius. So in words, you can do things like, if you have an intercepted arc, you have a piece of your circle that's 15 inches long and a radius that's 6 inches long. You can divide those by each other, the units cross out, and so you would have 2.5 radians for your angle measurement. Okay. This example here illustrates why people care about radians. Scientists and those that use formulas a lot like radians because they don't have any units. The degrees or the units always cancel off when you're dividing, and so a radian doesn't have a unit on it the way a degrees has a unit on it. So that is a pure form of measurement that people like who work with formulas, science-y, physics-y type people. Alrighty. So the question is, how do degrees and radians relate to each other? We're pretty comfortable with degrees. We know that there are 360 degrees in a circle, there's 90 degrees at a right angle. We know every quadrant has 90 degrees in it. But what about radians? Through the experiment we did in class, those of you that were here noticed that there were 2 pi radians in a circle. If pi is approximated to 3.14, that means there's 6.28 radians in a circle. Okay? We can make this equivalent 1 step smaller by dividing both sides by 2, because both sides do divide by 2, right? So we would say that there's pi radians in 180 degrees. And so that's going to be our equivalent when we're changing from one unit of measure to another, from degrees to radians or radians to degrees. We're going to use that equivalent, that pi is equal to 180. Pi radians is equal to 180 degrees. So if I start with degrees and I want to switch to radians, I'm going to multiply by that converting fraction like we did in chemistry class with unit conversions. I'm going to have to put the 180 on the bottom so that the degrees will be able to cancel each other off, and therefore the pi would go on the top. I'm multiplying my fractions together, so this would be, degrees cancel off, 30 times pi over 180 times 1, so 180. And then I need to simplify that. Some of you can look at that and know that 30 and 180 both divide by 30. So I would have pi over 6. But you may also use your calculator to simplify that. Fun fact. On a TI, which is what I have in my possession today, it would be 30 divided by 180, and then math button and fraction. So then it would tell me it's 1/6, and then of course I know it was 1 pi over 6. Okay, the one beside it, 120 degrees. Again, I would have to put the 180 on the bottom because I need the degree symbol to cancel out. Put the pi on the top. Remember there's a 1 under here. So I'm crossing out the degree symbols because they divide away. 120 times pi is 120 pi. 1 times 180 is 180. And then I'm simplifying 120 and 180 in my brain or in my calculator. I know that 12 and 18 both divide by 6, so I know that 120 and 180 can divide by 60, so that would be 2 pi over 3. Or again, I can use technology. Use your fraction key if you have your TI. I don't have one handy to show you. There's my 2/3 on my TI. Okay. We're going to skip down to something that's in radians. Here's what a radian measure would look like, something like pi over 2 or 3/4 pi. If I want to convert that to degrees, well, I want to put the pi on the bottom because I'm going to want the pi's to divide out, and I want to end up with degrees, so I want the degrees to be on the top. So I use the same converting fraction, but it's reciprocal this time. It's equal either way, so I'm multiplying by something that's equivalent to 1, whether it, which way it's turned. So pi cancels out. I have 180 divided by 2. 180 divided by 2 is 90, so 90 degrees. I didn't do a positive one or a negative one before, so let me do a negative one down here. I need pi on the bottom to cancel out pi. I need to end up with degrees, so degrees go on the top. Pi symbols cancel out. And I have to do -9 times 180 divided by 2. So in my calculator, -9 times 180 divided by 2, -810 degrees. Okay, that's all there is to it. Practice it, see if you have questions.